Welcome, everyone. Thank you for joining us for today's webinar. My name is Dan Abir, and I'm the Director of Sales and Marketing at M4 Engineering, and will be hosting the webinar today. Our webinar's title is Electrical System Complexity at a Tipping Point, and will be presented by Jay Sink and Lorena James from Oasis Sales. In today's webinar, we will cover the following: challenges faced by aerospace electrical system design engineers, how the use of digital technology addresses these challenges, how to efficiently design electrical systems and harnesses in the context of an aircraft platform, how the integration of ECAD and MCAD within Capital Topology enables both. We also included a white paper we thought you might find interesting called System-Driven Electrical, Electronics, Network, and Software Design, which discusses the impact of digitalization on EE systems design, the benefits of model-based system engineering, Siemens Xcelerator EE systems development solutions, and extending the digital twin. The white paper is available as a handout in the resources section of the webinar control panel for you to download and review after the webinar. Can you guys switch slide, please? Just a little housekeeping before we get started. The webinar will be recorded and will be made available by request and in a follow-up email to the attendees. Your microphone and video will be muted during the presentation. If you have any questions during the presentation, please type them into the question box in the GoToWebinar control panel question pane, and we will address your questions after the presentations. You can also look for updates and links to resources in the chat window. And of course, don't forget to download and check out the white paper in the resource section. Next slide. M4 is a leading provider of engineering services and software focusing on solving complex problems with insightful solutions. We can help companies from conceptual design through certification create more reliable and robust products, and are also a reseller of Siemens Digital Industries software. Spacebar, please. Our presenters today are Jay Sink. Slide, please. Thank you. Our presenters today are Jay Sink and Lorena James. Jay is the president of Oasis Sales and is a leading expert on using Siemens software to improve wire harness design, development, and fabrication. I will now turn it over to Jay. Jay, it's all yours.
Thanks, Dan. First, I'd like to thank you and the M4 team for the opportunity to partner together on this webinar series. Again, my name is Jay Sink. I'm the president of Oasis Sales, and I'd like to welcome you to our presentation today on electrical system complexity at a tipping point, featuring the Capital software tool. Before we get into the presentation, I want to tell you a little bit about Oasis Sales. Oasis has been in the electrical design software realm for over 20 years. First with Mentor Graphics, and now with Siemens Digital Industries software. I'm proud to say that Oasis is the first and only partner in North America to attain the Siemens top certification level of Smart Expert in the electrical system and wire harness design manufacturing. Our mission and goal at Oasis is to help navigate customers through their digital journey, partnering throughout the entire life cycle of the process from initial concept, deployment, and growth into production. Utilizing years of combined engineering experience over multiple deployments in a wide variety of industries and configurations, we bring proven best practices to help enable our customers to realize the shortest possible implementation times and time to productivity with Capital. Let's see.
Jay, are you all right there?
I'm sorry, went on mute.
Oh,
Our
okay.
focus today, we'll start again here. Our focus today will be on the aerospace industry. However, deployments of the Capital tool set are widely used in the automotive and transportation, marine, off-road, heavy equipment, as well as the medical industry. Capital software extends into the supply chain to the wire harness manufacturing industry, enabling better data transfer and full support of the production process, thus extending the digital thread and then minimizing disruption to increase efficiency and reduce errors and response times. Capital in the past has been viewed as a tool used at only the largest companies. Today, the adoption of Capital into small and medium businesses is exploding. And that's where Oasis focuses our partnerships to right-size a solution for you. Slide, please. In order to bring a comprehensive digital twin to life, Siemens offers the Xcelerator portfolio, which is a flexible, open ecosystem of software, services, and application development platforms that accelerates the digital transformation journey for customers. Xcelerator unlocks a powerful industrial network effect and blurs the boundary between traditional, standalone engineering domains such as electrical, mechanical, and software, allowing collaboration across product and production lifecycle stages. Slide, please. Thank you. So why do we need to change, and why are my tools of today not my tools of tomorrow? Today's product and production processes are becoming increasingly complex. The things companies' leaders need to consider today span from quality, personalization of products, being cost effective, agility, and scalable and sustainable processes. Complexity is a common theme across all of these topics, and it's growing exponentially. The platforms today, regardless of industry, are working to survive disruptive technology from the explosion of complexity, pushing the limits of our current systems and processes. Companies that can effectively manage the increase in complexity and the integration have an essential competitive advantage versus their competition moving forward. The Xcelerator portfolio provides the tools to manage that complexity across the entire digital thread. Slide, please. In today's webinar, we'll focus on the electrical aspect of the Xcelerator portfolio. Capital. What is Capital? Capital is a comprehensive electrical and electronic systems development solution to efficiently engineer today's smart products. It covers the design, the manufacture, and the service of electrical systems, as well as encompassing EE systems and software architectures. Capital can service the entire life cycle of needs for your electrical system and seamlessly integrate to the other systems within the ecosystem. The goal within the electrical domain is to diminish boundaries between mechanical, electrical, software, and simulation. Any separation between these concepts impedes successful collaboration, productivity, and innovation. Correctly executed, design reuse is enhanced, interdependencies are understood, and handoffs between domains and streamlined, creating real-time traceability across the entire digital flow. Slide, please. Thank you. The Xcelerator portfolio brings the digital twin to life, removing silos created by disconnected systems often seen today Xcelerator is the most comprehensive software model available today from any software manufacturer on the market, and it's only getting better. We look forward to working with customers to realize the bigger picture and the benefits of the Xcelerator portfolio. Moving on to our focus today, I'd like to introduce you to our presenter, Lorena James. Lorena is a leading application engineer at Oasis Sales. She has been working with capital deployments, support, and training for the past 4 years and was a capital user 2 years prior to that. I can attest from experience in working with Lorena on a capital deployment at a previous employer that Lorena was indispensable in the development of our capital processes from a user standpoint. She has seen firsthand what capital can do for a company's culture, stability, and growth. Lorena's key areas of expertise are in the electrical distribution and harness manufacturing aspects of capital. Lorena is based in the Chicago area, and you won't find a more passionate individual determined to help customers realize the benefits of a solid capital deployment. With that said, I hope you enjoy the webinar, and Lorena, I'll turn it over to you.
Thanks, Jay. So today, more than ever, it is getting more and more difficult to consume data coming from different tools and systems, especially in the aerospace industry. In particular, electrical and mechanical software tools need to work tightly together in order to successfully design an aircraft, reduce errors, and meet the hundreds of regulatory mandates. Slide, please. Not to mention having to manage the increasing complexity from increased volumes of electrical devices and units, which result in tens of hundreds of kilometers of wire. The electrical specification of everything needs to be met, and we also need to make sure everything is routed correctly throughout the aircraft. In addition, having to manage different configurations, yet still be able to easily apply changes to all of them. All this while meeting EWIS and other regulatory mandates required in the aerospace industry. Today, I will be talking about Capital, a Siemens solution that aids in electrical system development, embedded software development, harness manufacturing, and smart documentation. Specifically, I will be focusing on the capital design flow used by many of our aerospace customers that enables them to bring together the mechanical context with the electrical. Here we have a quote from one of our commercial aircraft customers. With the increase in electrical systems content in iteration and design, verification and compliance validation is so large that it can put a whole organization at risk. This is why we must change. So how can we help engineers? We do this with the concept of the digital twin. The comprehensive digital twin is more than a bridge between the digital and the real worlds. Companies are using digital twin technology to collaborate better, access data more efficiently, and make well-informed decisions to accelerate their development process. By creating a digital twin, companies are able to iterate designs, thus improving first-time quality without increasing costs. They are able to complete an idea and validate before they ever go off to manufacturing, thus decreasing or eliminating late design changes or having issues come back that might halt or end a program altogether. They are able to do this by breaking down silos between the different domains and increasing communication, in particular, the mechanical and electrical domains. Capital delivers a solution for the whole vehicle or aircraft lifecycle. On the left, you'll see it drives a full embedded software flow through to software running on ECUs in vehicles. On the right, it covers the electrical system design. It continues supporting engineers through harness manufacturing, engineering, and in-service publication creation. Capital is data-centric and built upon a data and process backbone to enable extremely high levels of automation, data coherency, and integration with adjacent domains such as mechanical design. This electrical data management system enables the traceability and changing configuration management that customers demand. And because the electrical systems are part of a wider program lifecycle in organizations, we provide deep integrations into PLM systems such as Teamcenter and other necessary domains throughout the product development process. With the exploding complexity of electrical systems, development happens in the context of model-based systems engineering. To deliver this, we integrate with other domains to deliver a truly integrated system development, including MCAD, PLM, and ALM systems. So how do we realize the digital twin in aircraft design? I'm sure many of you have experienced some of these problems that we're going to discuss. For example, for an electrical engineer, it is hard to understand how the wiring is fitting in the context of the aircraft because they don't have the whole picture. You have wires going from device 1 to device 2 without knowing where they lie in the aircraft. Any changes that need to be made need to be communicated between different domains and among different engineers with different understandings of the data. Then the changes are executed manually, which leads to errors and late design changes. How do we help solve this? The ability to have a topology of the aircraft creates an interface for both the mechanical and electrical engineer to communicate in. The electrical engineer can design in the context of the mechanical, and when it comes to communicating changes, there is an actual data exchange, not word of mouth or email, meaning no misinterpretations. This leads to less manual mistakes, having all the data synced up, and improving first-time quality. Now that we understand the problems and what the solution should look like, we'll talk about how we can achieve this using the Capital software. In Capital, we start with a system-driven design approach where we begin with nets or signals, and using Capital's automations easily create the wire abstraction. This includes the generation of harness-side connectors, including modular ones, which are becoming more and more prevalent in the aerospace industry. We then use these same wiring schematics and synchronize them to a 2D aircraft topology that allows you to reconcile differences between the mechanical and electrical design. The topology abstraction allows an electrical engineer to work with the mechanical content within the context they understand and are most familiar with. This automation and correct by construction design ensures an optimum design process. Some of the automation capabilities used in this part of the process are the conversion of nets to wires, wire naming rules that allow you to auto-generate wire names based on given parameters, automatic creation of harness-side connectors, including modular connectors like I previously mentioned, and traceability of wires through different diagrams and systems. These wiring schematics can then be mass imported into the topology, which we will see in a video during this presentation. The next step in the electromechanical design process would be to sync the wire schematics with the 2D mechanical topology to validate the physical wiring. Once we have the physical wiring schematics and we've synchronized the topology view, we need to feed back mechanical data, specifically inline connectors that might need to be added back to the wiring schematics. These are placed in the context of the physical aircraft, or any vehicle for that matter, and accurately added to the appropriate system's wiring schematic. We will see this in the following video. Here we are starting off in the topology plane with a UAV aircraft that has been brought in from NX. The wiring schematics have already been synchronized, and we can see this by the list of wires on the left. We can also trace back to where these originated by tracing back to the physical source. This will take us back to where the wire originated, which is in the schematic. Back in the topology plane, we can see that we can trace the paths of the individual wires. The list of wires on the left is actually a list of wires that are unrouted, but we can use our routing assistant, which will be the dialog box you see pop up here on the bottom, to complete the routing of these wires. Here you can see that it is telling us that the specific wire we've highlighted, in order to go from device A2 to A3, it needs to travel through two different bulkheads or inline connectors. We can also run the routing assistant on the connector pair itself to view all of the wires that need to be routed through the particular inline pair. You'll see here that there are actually 8 wires that need to route through the inline pair, so we can go ahead and complete the route for all 8 of them. We do this by choosing the Place Inline Connector button here, and then the information will be transferred back to the wiring schematics. You can see now that the inline pair that we chose to route the 8 wires through has now been added to the schematic. We know that this is the correct path because we have seen it in the context of the aircraft topology. Coming back to the topology plane, we can see that there is another inline pair that these wires need to route through in order to complete their route. We can run the routing assistant on the connector pair itself to see what other wires need to run through the pair to complete their connectivity. We can also run a connector report, and this will allow us to see the cavities that we have available and compare it to the wires that need to run through the connectors to make sure we have enough space. We can also make sure we have the correct size cavities for the wire sizes that need to run through the inline pair. And if we don't have enough space, then we can communicate this to the mechanical engineer and either change the connectors at this bulkhead or add more inline pairs to create an alternative route. Here we had enough space, so we can go ahead and place our inline connector, and we can go ahead and place it back in the wiring schematic. Here you see this insertion view of the connector, and we can see what wires are going through each cavity. This is handy because, say for example, you know you're routing a multi-core twisted pair, you can adjust which cavities the wires go through and make sure the multi-core wires route through adjacent cavities. Coming back to the topology view, after we've synchronized and updated the information from the wiring schematics, we can now see what wires are still left to be routed. Once we route the last set of wires through the last pair of inline connectors, the inline will be placed back into the schematic, just like we did the other inline pairs. And we'll go ahead and complete the connectivity for all wires. Back at the schematic level, we can go ahead and clean up the schematic by merging any connectors, for example, that have been sliced up. As you can see, for an electrical engineer, being able to work on the electrical connectivity within the context of the aircraft or vehicle, it is easier not only to update information, but also communicate any changes that are required across domains. Here back at the topology level, we see we have no unrouted wires, so we have gone ahead and completed our connectivity. Another capability within this flow is being able to view the relevant 3D data within Capital to aid in the visualization of EMI categories and better meet space separation requirements. We begin by importing a signal separation file with minimum EMI category separation distances. Then we can use the 3D viewer for signal separation to be able to see the other plane. With the use of the minimal distance file, design rule checks will show if any of these are violated, meaning if there is a wire that is traveling along a bundle that does not allow it to meet the EMI specification distance. Viewing these results in the output window, which is interactive, so it will take you to the specific path violating the rule, allows for easy manipulation to reroute wires, just like we saw in the video before. All in all, what we are really doing is establishing a full digital thread throughout this flow. We are able to collaborate better, access data more efficiently, and make well-informed decisions to accelerate the development process. By creating the digital twin, we are able to iterate designs, thus improving first-time quality without increasing cost. As you saw, we are able to get a complete idea and validate without ever going to manufacturing, reducing the chances of late design changes or issues coming up that might halt or end a program. We have seen great success with our aerospace customers, and here you can see some examples of their successes. For example, 99% manufacturing ECO reduction for a flight simulators company, 50% electrical design time reduction for a satellites company, and first time ever zero scrapped wire harnesses for a helicopter company. Next slide. And now I'll turn it back over to Dan for our Q&A session.
I was so enmeshed in the presentation, I forgot that there might be some questions. I was about to just remind people to, first of all, Lorena, thank you so much. It was really good. But just to remind people, please enter any additional questions you might have into the question pane. I thought it was very interesting, but each one of you might have a different perspective in an area of interest. So feel free to enter the questions, and let me see. I have one question here from Jim. What MCAD, what mechanical CAD systems does Capital integrate with?
Capital integrates with Siemens NX and Solid Edge. We also integrate with CATIA V5, V6, and V4, SolidWorks, and Creo.
Okay, awesome. Thank you. Here's another question. This one came in from Joe. Can multiple users work on one aircraft concurrently?
Yes, the system design approach allows engineers to work in separate designs or aircraft systems, and you can even have two people working in the same design. Okay, excellent. Thank you. And let's see. Oh, one last question here. Just to remind if anybody has additional questions. How are EWIS, electrical wiring interconnect system regulations applied? So Capital has the ability to create rules and constraints. So you can create a rule that specifies which wires can or cannot be routed through specific bundles based on existing parameters. For example, like an EMI category set on a wire. Awesome. Thank you. So it seems here that we have no more questions at the moment. For all of the attendees, please feel free to ask us questions down the road. We'll provide you with the contact information. And so with that, I wanted to say, Lorena, thank you again for putting this together. And I'd like to turn it over to Jay to wrap things up.
Okay. Slide, please. So thank you, Dan. Thank you, Lorena. Hope everyone enjoyed the presentation. If you're interested in what else you can do to move your team towards exploring things that you might have learned today or might help your organization, or maybe there's just something else that we can do to help you down the path of the digital enterprise, please reach out. So here are some of our thoughts or ideas of how we can start exploring together what's next. We can schedule a short call to discuss your current situation, challenges, and impacts on your business. Depending on the area of interest, it could be either Oasis Sales, M4, both, plus Siemens that can help you out. We could schedule a short process audit to better understand how you are leveraging, how you could leverage Capital's electrical system design processes to reduce costs and improve efficiency. And of course, you are always welcome to send us an email with any additional information you would like to share or receive. My contact information is on the screen. Please use me as a primary point of contact, and depending on your need, we'll get the correct resources engaged to get you an answer. I did want to also remind you that there is a digital handout available for the download on the link on the webinar. Dan mentioned that earlier. The handout is titled System-Driven Electronics Network and Software Design, and goes into some additional detail relevant to today's discussion. A recording of this webinar will be made available by request on demand on M4's website and on Oasis Sales YouTube page, as well as in a follow-up email that will be sent out to everyone that registered. So with that said, thank you everyone. We appreciate you attending, and please reach out to us if you have any additional questions. Thanks again for joining us today, and we look forward to seeing you next time, and have a great day.